So we'll jump right into it. Thanks everyone for jumping in. I'm really excited to see lots of folks interested in Git and what we might be able to chat about Git. And I'd say just ground rules real quick for the presentation. Feel free to hit me up on the Q&A in the chat. I'll try to keep an eye on it while I'm going, and I just prefer to have those questions come in as we go. So if you have a question, wondering about something, feel free to just toss it right in, and I will attempt to answer it as we go. And I should preface this by there are people that are smarter at Git than me. But I tried to put together kind of some concepts and some ideas of things that, when I've helped folks learn about Git, especially folks that have an embedded background, what are the frequent challenges? What are the frequent kind of questions that people have, and where do they get stuck? So we'll try to chat about that. So real quick, my name's Joe Schneider, family man, dad of 3 girls, amazing wife. Embedded software for 20 years, done a lot of agile transformations, and it's kind of that whole agile thing kind of happened along the same time as all these distributed version controls things came along like Git. So we'll talk about that in a sec. But yeah, it's kind of an enabling tool for a lot of that, and then just a passion for improving the state of the art. Dojo 5, just real quick, we're embedded software group, services and products company out of St. Paul, Minnesota. Dojo, we're all about immersive learning, and 5, we've got a foundation in family. I got 5 in my family. So, and we try to bring our clients and our in the broader community like you guys into our family as well, and share what we see as modernizing the firmware lifecycle. So real quickly, the plan for today, what is it and why, and the concepts, some hard parts, advice from some noobs that I got, some former noobs, I guess, some advanced use cases or thoughts about that, and then embedded specific thoughts at the end. So real quick, since we've got, could have a large kind of variety of folks here on the thing, I want to set up a quick poll here, and this is basically what's your Git experience level, and what is your Git preference as far as do you use CLI or do you use GUI tool? And I'm kind of curious what you guys think, and I want to get that so that we can just kind of, so I can tailor this low, high, and just building up this question here. Never used it. Yeah. Okay. So I think I've got this poll set up here now. Launch poll allow. Okay. Here we go. So if you guys can fill that out, you should have just gotten a poll in Zoom, and that'll help me kind of give a good idea of what our audience is looking at like right now. All right, cool. Sounds good. Well, I've got 80%, 90%, come up on 90. All right, awesome. Thank you guys. So this is great. We've got a large majority of the folks on this call have either never used Git or have a very low experience level on Git, and that's great. I've kind of tailored the presentation for folks, yeah, there's a couple of folks who are listing themselves as high experience level, and feel free to jump in if I say something or you got something that you could add to the conversation. Jump in on the chat, and I think that would be great. I think, yeah, so that'll help me. This will be great. So real quick, bringing the presentation back up here. What and why do we need version control? What is it? You know, and kind of some history about it. Subversion, CVS, there were a couple of really kind of old school version control systems back in the kind of 1990s. I think as software in the 1980s, 1990s was starting to get a little more complex. We started to have more than, you know, just teams of 1 or 2, but maybe teams of 5 or 10 or 20 people all coding together. Realized that, hey, there's a need to have some kind of tool that we can collaborate on these things with. Where do we store all our source code as we develop? And then there's also, regardless of whether you're a large team or an individual working on source code, you're gonna add a bug, or you often find yourself in a situation where you added a new feature and then a bunch of other features broke that were unrelated. Maybe you go days before you realize it, and then all of a sudden, how did that happen? And what do we do about it now? Because I don't really remember what I did over the last, you know, 2 or 3 days. So that's really what version control helps you do, is show our differences between the changes as well. And so you can kind of back up to old changes, back up to, you know, see exactly the changes that you made. It stores all of that in kind of a timeline of like, you can, you know, think about social media or almost as timelines that are similar, right? You can kind of see evolution of thoughts or evolution of your code in this case. I listed out a couple old school ones, CVS, SVN, others. All of these have a central server, and that's really the big difference here between like where we were with these older school version control systems and the new systems like Git. There was a centralized server, and you had clients, and you always had to be connected to them. This is like I don't know, almost like your bank or something. You had to kind of make a deposit in the bank whenever you interacted with your version control system. You had to check out things, and so that's how it did. And then in the initial cases like CVS, there was some support for branching, which we'll get into too. But some of that branching was a little. You can see how this might not scale if you have lots of branches, right? Their idea being 1.2.4, 1.3, you know, so you've got all of these different numbers. And I used a couple of these old school systems. And I have a story for that in a sec. But yeah, so the big why was in 2004, 2005, software developers were fed up, enter Git. Main reason I believe is that just the old school stuff was slow. There were a couple other things happening there too. One is the Linux kernel in particular had been already moving to a proprietary, they were on BitKeeper, which was a proprietary version control system that they were already rubbing. You know, you can imagine open source people with the Linux kernel not rubbing right with the proprietary tool. And unfortunately that, like, Linus got fed up and he's like, screw this, I'm gonna go like build something better. And so that's when Git was formed. Really, it was Linus Torvalds, the creator of the Linux kernel, that had created this. And so I think it was slow, but it was also like they didn't like the idea either that like the centralized server, whoever owns that server, whoever hosts it, they kind of own your code, and you don't really have an opportunity to you know, what happens if they get angry? What happens if they run out of money? You know, like is the Linux kernel toast at that point? So that was another big reason for these folks. They said, hey, we need to get rid of this centralized server. We need to distribute this and get this distributed stuff. I've got a link there to some historical articles on Git. I'll send out a survey after this, and I'll send you the slides if you fill out my survey. So that's our little trade there. But I've got some kind of interesting references in here too. So another guy at the same time, Matt McCall, who's actually lives in the Minneapolis area where I am, he created a competing one called Mercurial. They had some different ideas early on. They've largely consolidated on pretty much the same way of operation. There are some differences deep down underneath, but largely a couple of terms are different, but they mostly work the same. Facebook famously chose Mercurial. I worked at John Deere for a number of years and helped them switch over from a really, really bad old school system to a Mercurial flow. And at the time, Mercurial just had better support for Windows, and that was kind of our big reason. Largely now, support for either of these systems is pretty much the same, and you're not going to see too many differences. There was a big I mentioned similar speeds there, and that kind of flows into the next topic. But there, there was a big optimization that happened. Initially, these things were okay, but they weren't great. Like they had some scaling issues for very large projects. Like initially, Git, took little time on this huge Linux kernel that had a lot of commits and had a lot of history behind it. But they've largely gotten quite good. And there was a big kind of you could read about it in that article I linked before, but there's this big kind of arms race almost as Mercurial and Git were kind of vying for supremacy and having to do with like how much space does it take up on your hard drive, all of your source code, and how fast can it check out, how fast can it commit. And largely those are over. They've both kind of, really, really optimized it. It's kind of amazing how fast it goes sometimes. And yeah, my quick story on this is when I was back at John Deere, we used to use a version control thing called a Star Team, and that used the version control versioning that I mentioned up here. So each file, not necessarily the whole repository, but each file had its own version. And you might think that intuitively made sense, and it did make sense for a long while. But when repositories get really, really large, that becomes kind of an issue. When I had the question as a developer of like, do I have the latest code, and needed to do what Star Team called an update, that could take half an hour. And it was sending, for every single file, it had to send an individual request to a server to say, is this file up to date? And then is that, and then the server would have to come back and say yes or no, and here's the information. And that, yeah, for a 10,000 file repo, that I went and grabbed a cup of coffee or two at that point. And so it was definitely, and then the magic was really when we moved to Git, we could do that same operation, like, do I have the latest stuff, in half a second. So it was like game changing just from that piece of things. And there are a number of other things that are great about Git. But yeah, so I would say at this point, most of the world has settled on Git. Mercurial's still out there, and it's an interesting thing to know about and learn about. Some of the tools support it, but I think support is going to start to wane. Git has kind of provided the tools we need, and has, unfortunately, I would say Mercurial was easier to use from the command line than Git. But because of the large open source community behind Git and Linus Torvalds kind of sign off on it, I think that's a large reason why Git won. But yeah. Anyways, so let's get into some concepts. So subversion. On the left side is kind of this old school, what used to happen in the image here. We've got a repository, and a repository is just where all the versions of your changes are held. So this isn't just what you're currently working on, but what everyone has worked on for all of time on your project. And so that is, that can be large, and in old systems it was, and then we'll get into it. But in new systems like Git, there's been a lot of optimization there as well to keep the repository small. And you did actions, you basically, on your computer down here, you had a working copy, is what it's called. And that's basically just the set of files you're working on. And really more than that, it's the whole set of files. So it's like, maybe you've got an embedded project that has 1,000 files in it. Or maybe it's only 50 files or something, right? Some kind of smaller application. And maybe you're only working on one file, but you need all 50 files on your hard drive in order for the compiler to run. The compiling here is all still happening on your local machines. Like, we're not talking about moving that at all. But you need a snapshot of the entire system and all of the files in order to build and compile and do your work. So that's called the working copy. And with Subversion, what you'd do is you would do an update, and that would pull down all of the latest versions. So if your buddy or whatever at your company, some other place, some other open source thing had made a change to a file, you would run update, and then you would get the latest updates. And then when you made a change locally to on a file on your computer, you could do a commit. And then that would commit it to the local repository. And then that would store all of those changes inside of the Subversion. Now, for either a commit or an update to happen, you had to be connected to Subversion. You had to have internet, and the server couldn't be down. And so that created kind of this bottleneck, and that's what we call like centralized version control systems. And that's really largely what existed prior to Git and Mercurial. The opposite of that, or the kind of what we're talking about today, is the distributed version control systems, which is Git. And you can see that the big difference here, besides a little bit of terminology, is that we got a local repository in the red. And that means that we moved the repository out of the server space and onto your computer. And so that means you, locally on your computer, when you're using Git, you have a copy of all of the differences and the entire change history for all of time for your project. You might think that's really, really big, but I have a fact in a second. Like the Linux kernel, which has hundreds, I don't know if it's hundreds of thousands of commits yet, but probably. I guess I haven't checked. But it's lots of commits in 25 years of history. It's only 1.5 gig now with the latest versions of Git on the system. So it's pretty darn optimized. And it's compressed and everything. So like, and not only that, but it's very searchable, and you can quickly jump between things too. So it's amazing the engineering that has gone into this to make it optimal. But yeah, so you have your working copy that you check out, and that's what you're working on. And then when you make a change or do a commit, the difference here is that commit happens completely locally on your computer. There's no communication over the network or internet with commits. They just get stored in your local repository, your Git repo. You can do things like log, which lists out a lot of basically the Git timeline on your computer locally. Again, you don't need internet. You have all of the logs and all the differences locally in your machine. And you can do some other operations all locally. It's kind of, there is still this need to collaborate though, of course. And so we need to have some way to exchange information between repositories. So we kind of get this idea that there will be not only the repository that's on your machine, but there's a repository on another person's machine. And then there might be a repository in a central location as well, so that we have a place to connect and gather each other's changes. And so it's not necessarily that in a distributed version control environment that we don't have a central server. We typically need to if we're collaborating with other people, but only from a kind of conceptual level. We don't, like, the technology of Git does not require a central server. And so we had this need for some new concepts, because previously commit meant you both locked in your changes and you shared them with everybody. Now commit just means you locked in your changes locally, but you haven't shared them. So these new concepts are called push and pull. And so you can push your changes. And now this is commits that have already been created. So you're kind of pushing your timeline of changes out to a remote repository, and then you can pull or fetch changes from the repository to your local repository. And that is the way that we work through and update our systems now. All right, so I mentioned, there's this kind of common concern about what about the whole repo on my computer. I mentioned it's very heavily compressed, only stores deltas, and it turns out to be totally fine. Hard drive space is cheap, and yeah, I think that's the biggest reason that the local repository is nice, is because you get to see all the changes and operate on all the changes in your code locally without having to talk to the server, and that makes it fast and very scalable. The requirements for your centralized Git server are pretty low, and a lot of the number crunching and searching and all of that can happen locally on your computer. I think speed is really the largest reason. There were people when Git came out saying like, oh, look, I can commit on a plane or whatever, and they were very excited about that. But I think largely that's kind of for fun, and where this really is like practically better is when it's, like it just moves faster. It's faster in a lot of different ways. So just some basics, we've kind of touched on a little bit, but a commit is a set of changes kind of collected together. There are a couple hard ones here, and we'll dig into them during the demo stuff. But one of them is called a staging area, and that's not represented in the image. But basically, as you work to create a commit, you have to collect. Git has this idea of like I might have 10 changes in progress right now, but maybe I only want to lock in 2 of those changes, but then the other 10, other 8 I want to wait with, and there's something else that I'm working on. So it's kind of almost encourages this like parallel path of like working on multiple things at once, which I don't necessarily condone, but it kind of encourages that. So, and I'd say that this one sometimes is hard for people to get their head around. Mercurial did not have this concept. Basically, you committed everything that was changed in your working copy. So Git has this idea that the working copy can have 10 changes, but your staging area might only have 2 changes. And the staging area is when you actually perform a commit operation, that is what gets committed. And then merging, and this one can be hard too. It depends on your tooling a little bit. But this is combining changes from 2 commits. So let's say that both yourself, once you don't have a central repository, that means that you and your buddy can both be working on the same code at the same time and not realize it. And then you commit it. And now you've got 2 repositories, your local repository and his local repository, or her, and they both have different conflicting changes. And so how do you resolve that? Because you won't even know until you push out to the remote repository and kind of collect your stuff. And so that's one of the kind of tricky pieces too, or it can be tricky. I'd say a rebase is another thing, and we'll talk about that in a second, but that idea is like moving commits around. Sometimes there are reasons that we want to change the timeline. And then a remote, and I've kind of been using that term, but a remote is just basically a repository that's not on your own machine. It can actually still be on your machine, and you can have 2 repositories on your machine, 2 separate Git repos, and one can push to the other, and we'll show that a little bit here. But so yeah, so those are kind of the basics of some of the terms that you'll hear, actions that you can perform on a Git repo. And so commits, tags, and branches are another big piece of this concept. So if you think of each of those circles, and this timeline on the right side is a common way to kind of visualize Git commits and what we're doing. So like imagine progress from left to right. And so that this initial blue circle is a commit. So that's a set of changes that we made that we wanted to save. And then what happens effectively when you check something into Git is it gets a hash, and this is a cryptographically secure hash. Not your code is encrypted, but it's more that it's very hard to come up with changes that will come up with a certain hash. It's the hash is very. It uniquely identifies that set of commits. And in fact, it's a large enough size of a hash that it uniquely identifies that commit for the world, really. It's large enough that like mathematically, probabilistically, you will not have a hash the same as anyone else in the entire world at any time. It's very, very unlikely. We'll see those in a sec too. They're typically listed out as hexadecimal values, and then what happens is that each of these commits then has a hash that's associated with it. And when you then build upon a commit, create other changes on top of it, that commit includes only the changes. And those are compressed and then hashed, and so that's the commit then gets a hash number that uniquely identifies that commit. And then the commit also has a pointer back to its parent, so it always knows the commit that it's based on. And this is important because, of course, if you're only grabbing deltas or the changes between different files, that they necessarily depend on their ancestry. Like which version of the file did I build on? And so, but then that forms this chain of commits, really, or this chain of code that all starts from one particular place and then builds on it. And so, effectively, when if me and my buddy are both working on the same code and we both make a commit, we've effectively created two different branches of code. And that's what can happen here is we, one person, might have created this change on purple, and another one might have created this change on blue. And so then, we've got an issue that we'll talk about in a sec, which is, how do we resolve that? But yeah, that's kind of the idea of commit, is they're kind of an all-in-one encapsulated, these are the changes. And the other kind of interesting concept, and this one again is a little hard for people, I think, because it's used differently in Subversion and CVS and some other kind of older version control systems, or if you haven't used version control before, it's probably a fairly new idea, but it's often useful when we have these different branches. Sometimes we intentionally create branches because maybe we've got like a version of our embedded device in the field, and we've got another version that's being worked on actively, and so the code bases have diverged, and now we need to do a hot patch for the device in the field or something. Now we need a branch or a tag to kind of identify what we're doing. So that's what these little boxes are, and I find, like, especially folks who know C or kind of are into embedded programming, thinking of these tags and branches as pointers to a particular commit is really the right way to think about this. These are just pointers. They're names, they're extra metadata. They exist in a separate place in your Git repo, in kind of the data structures that Git stores, and they point to a particular version of a commit. So master is one that is kind of built into Git, and it kind of represents kind of the mainline code development. And that one we'll see has some has some basic has kind of some built-in functionality with Git. And then you can create tags or branches however you like, pointing to other commits. The big difference between tags and branches is that tags don't move. So typically tags get used for to say, like, to mark like this is version 1.0 that we released to the field. We're never going to go back in history and change that. It's 1.0, fine. But things like I'm working on a branch that I'm working on right now, and I might have 10 or 12 commits, and maybe I'm only halfway through, but I want to mark it as a branch. That is, marking as a feature branch, for instance. Those branches then move the pointer moves along with the branch as you make commits, and that's kind of the big difference between them. And they will move all the time as you do development, unless you're for branches. Tags don't move. All right, so then real quick on merge versus rebase. So as we talked about in this middle picture, and this timeline now is being viewed as going down here, but say I've worked on this yellow timeline and I've made some changes, and somebody else has made maybe similar changes or overlapping changes on this purple timeline. In that case, we've got two different timelines basically that need to be resolved, and there's actually two ways to do this. One is using a merge, which is represented on the left, where we find a way to integrate the changes from the pink timeline onto the yellow timeline. And sometimes this requires us to merge things manually to kind of resolve things. But in a lot of ways, and we'll see this too, Git is pretty good at guessing what you want in a lot of cases. And then in cases where it can't guess, then it asks you for feedback. Rebase does something a little different. So if we have the timeline for yellow, and we want to keep, in many cases, it's like out of a desire to keep a linear timeline. Then we go from yellow to pink, and now we have, basically this requires us to change the parent of this first pink change. And so and really it's kind of replaying the changes on top of the head of the other branch, and the head being just the tip of that branch, the latest change on a particular branch. So there's kind of the difference between them. They're two separate operations in Git, and they require slightly different ways of interacting. All right, and then the last concept I just wanted to introduce, and feel free to do some additional, we won't be talking about this too much today, but it is kind of a big concept that gets used a lot when folks are talking about Git, is something called Git Flow. you've got all these tools, all of this power. You can have branches and tags, but how should we use them, right? Can we come up, because it can kind of turn into chaos if you just kind of use it willy-nilly. And so some people have had this issue. They thought about it a while and came up with this thing called Git Flow. So it's really about, you know, how to use the tool from kind of like a team level. And the idea being that we have different branches. And so these lines here, these vertical lines are different kind of development lines or code. And you can see time is going down again on this particular image. And so on master, which is on the far right here, say we've tagged our development at 0.1. So this is maybe our first release. Now we need to continue doing some development. That happens on a branch that's often called develop. And by convention, we call it develop, and then people kind of know what the expectations are when it's called develop. Now, develop can have, you know, actual development on it. Some teams choose to break this down even further if you're a larger team and build feature branches. And so this way, you know, like a partially completed feature doesn't end up on develop. Typically, expectations around develop are that it always builds, and that usually that your application actually runs and doesn't crash and whatever on develop. And so, you know, sometimes you're in the middle of something and you need to commit something, try it out. You know, you're working with one other person on it or something. You need to integrate your code, and it's just not ready for develop yet. But that's what the feature branches could kind of help you do. So the idea is that on these feature branches, you would be working on different items, and then as that feature becomes mature and you're ready, it's kind of meets the criteria for what it takes to merge it back into develop, and you can merge it back into develop. And they fairly intentionally choose merge as a strategy and don't do a lot of rebasing in Git Flow. And there are some folks that agree with that or disagree with that, but that's kind of the Git Flow model. What happens if, of course, if in the middle of develop, you have a hotfix that needs to go out? Well, this is how Git Flow handles it. Defines a hotfix line. You create the patch based on the 0.01 tag, create your changes, and then you check it in back to master and tag it with 02 as you released it. So, and then this also allows you to pull that hot patch back into the develop line as well, because presumably the same bug that needed to go out to the field also needed to be incorporated into develop. So a couple different ways to kind of think about that. We've also got, what if we wanna, you know, so maybe we're kind of done developing. Oftentimes in development, there's a hardening or kind of a like feature freeze where we're just trying to fix bugs and kind of wrap up the project, do it, you know, final QA on it and stuff. And that's what we call release branches. And so, you know, when you're not in hotfix mode, but you're in kind of a more controlled mode of releasing, then you walk down this release branch path and you can do, you know, basically do your hardening. And then when it's final check off QA, whatever, you know, like you're ready to release it, then you push it out to master for the final release. So yeah, so kind of just some different ways about how to make branches. You'll find that I think most projects will loosely conform to this. There are folks who have, you know, religious issues with one or the other of, you know, some of these items, but for the large part, this is what you'll find Git following if you try to contribute to an open source project, or even if you're kind of working on your own. This can be a nice kind of flow to use, give you a little more structure around what you're doing. All right, so I want to show a little bit of what this, we've done a lot of kind of theory here. We've kind of laid the groundwork for how this, you know, some things can work. And I wanted to kind of just walk through, what does this look like from a, from the command line standpoint. So let's see, talks, Git, okay. So so right now I've got an empty directory here and I'm using some bash commands. I assume you guys know some of these, but you know, feel free to hit me up afterwards if you have any questions about just the bash piece of this in general. But here I'm gonna make a directory. Maybe I'm gonna work on a new project, right? Actually, let me use a hyphen here. And inside a new project, you know, I don't have anything yet. but I want to set up some new project. So I can do a git init. And this, so prior to this point, it's just a regular old directory. If we, you'll see, so Git Status says it's not a Git repository. But if I want to make it a Git repository, I do git init. So now it's initialized an empty Git repository. That's basically, we have the structure, and you see that Git stores all of its stuff inside of a hidden, this is a hidden folder inside of this, and this is that's what makes it a Git repository. If we do you know, an LSLA, which shows us all the hidden stuff, then we've got .git, and if we kind of jump inside of there, you'll see there's kind of there's some basically internal data structures for Git, and this is where it stores all of its stuff. We don't necessarily need to know what goes on in there. If you're interested in figuring and deep diving into all of that, I'd love to do a follow-up talk on like deep internals of Git. Let me know after this if you're interested in that. But for now, we're going to kind of just let that be. It's kind of a black box to us, and Git just works. If we do a Git status, which will show us the logs, or will show us you know, what's in. It gives us some information, right? We're on branch master. That's because that's the default branch, and we don't have any commits yet. And there's also nothing to commit. It's really talking about the staging area at this point. And so we've got a clean Git repo. If we do Git logs, that's another, or I'm sorry, Git log, that's another tool that will show us the timeline. And of course, right now, branch master doesn't have any commits yet. And so that, you know, we're not able to see a log yet. If I, we'll just pull up Visual Studio Code. And once that pulls up here, I will, yeah, so I don't know if folks use Visual Studio Code here, but that's what I tend to use for a editor. And here we've got our blank directory. Let's just create something, you know, like main.c. This is our embedded thing. We're gonna, I don't know, include some stuff, and we're gonna have a main directory, right? We make a very simple C program or something. We don't need to include anything, right? Boom, we got a C program. Now let's go look and see what's happened over on the Git command line. So if we do Git status, we're going to see something new. It's going to say, well, you're still on branch master. You don't have any commits yet, but we have some untracked files. And that's the way the files start. And it actually gives you some nice, you know, heads up. Hey, if you want to add files, you use git add. And so we can do that. And really what that's doing is that's adding this version of main.c to the staging area. Now, if we do a Git status, we're going to see it looks a little different. Now we've got changes to be committed, which is code for our staging area. And you'll see they play around with the terminology, because then it's giving you this hint of, hey, if you didn't mean to, you can do git rm -- cached file to unstage. So if we're like, oops, you know, those changes to main, I'm not quite ready to check those in yet. You can just do that. And now like the tricky part about RM is, like, in this case, when you do -- cache, the file is still there. It's not that you've deleted it off your hard drive, but it is removed from the staging area. So this is where the Git usability could be better, I guess I'd say. Here, I'm just realizing I should probably up the font size a little bit here. So yeah, so let's say we did though. We want to add main.c, and one shortcut that for you guys is git add dot. So if you do git add dot, it will recursively add all of the files that are open. So like, let's say you've made 30 changes in some deep directory tree. You don't have to type every single file name. You can just do git add dot. It'll add everything from the command line. Now we can do git status, and we can see that, okay, main.c is ready to be committed. If we do a git commit, and you need to actually provide a commit message as well. If you try git commit, well, it'll pop you into VI, and if you guys aren't familiar with VI, you have the most of what I know about VI is how to get out of it when I accidentally find myself in it. And you can see I started typing down here. It's a :WQ to get out of it. And in this case, I didn't provide a commit message. What I like to do, and what seems to be easier for a lot of people, is to just use the -m flag. And this is a commit message. In general, when you're doing commit messages, you know, and team, I don't know how many of you have been in that situation, but you want to try to keep them, you know, not like, you know, I did work or I typed or whatever. You want to try to make them informative to help people when they're looking, because you get these big timelines on projects, and then you want to be able to see what was done, what are people working on, and sometimes that's clear and sometimes it's not. So, you know, in this case, you know, added, you know, the main function or something might be a good thing for me to use as my commit message. Once I've done that, I can commit it. Now you can see I get some stuff here. And this, what's happened here is I committed to the branch master. This is actually the root commit, so that's special. You won't see that again, because that's basically saying this is the very first commit of this whole repo, and it has no parent. And that's very unusual for most commits. It only happens once in every repo. So that's something special. And then you see this, which is the hash. And typically the hashes are given in this way, you know, 6 or 7 characters. And really, and now you can see that we have nothing to commit, where our working tree is clean. So we now have, you know, our working tree matches our staging area, and our staging area matches the current commit that we're on. If you go to the log, we can also see that here's the long form of our commit hash. You can see that this hash is just the first, whatever, 7 characters is what's shown here. So this is really just showing the hash, but this is the full hash. This is what gives us kind of like cryptographic level security on this hash. Like, this hash is unique in the whole world. I dare you to, you know, make a commit, even if you use the exact same, you know, stuff that I did. The commit will be, the timestamp will be different. And so this commit hash is unique to me forever. And I added the main function, so you can see this list here. And you can also see that we have a pointer and a tag, and I probably should have put that on the tags and branches page, but this is a special tag that always points to whatever your next commit is going to go to. It always points to the next, the commit that's going to be the parent of the next commit. So if I were to do another commit, it would be parented by master right now. That's why its head is pointing at master. If we go back to code and I make some changes, maybe I want to print, you know, I don't know, hello world or something. Okay, now I've made a change. Now we can use the Git. Now if we do a status, it's going to say something a little different that we, again, haven't seen before. Changes not staged for commit. So it's not as before, you know, before it was saying untracked files, and it was red. Well, now it's saying that it's been modified. So it knows main.c is already in the Git repo. It's just that you've made changes. Well, we can do a Git Diff, and that will show us the changes that were made. You can see they kind of give it the names A and B just to compare. If you haven't read patch, this is kind of like a roughly a patch format here. And it's showing that there's differences between A and B. That's basically before and after. And then the main change you see here, the plus means we added the line, and then printf was what we added. So it knows what we did, and it's aware of what needs to be done. So at this point, if we just did a commit though, you know, nothing happens because we haven't staged it. So that's one of the tricky parts, is just make sure you're staging it. So we have to add it first if you're going to use this. Now, if we do status, we can see that, okay, it's modified and it's green now because it's changes to be committed. So now main is going to be committed. And, you know, again, it gives you the way, the kind of the special command to unstage. You'll notice it's different now, RM versus restore. This is why I typically tend to use GUIs rather than CLIs, because the Git CLI is a little weird in a lot of ways. Like when you want to do similar operations, the commands change. But this is what, you know, so now we're ready to, now that we've added it, now we can commit it, you know, next change. And now we're ready to, and that was a terrible commit message, but now we're back to clean. We're on a working tree clean. We're up to date with the Git. And now if we do log, we can see there's two commits, right? This is our original one where we added the main function, and we've got the whole hash here. And then this is the next one where we committed to master and made our next change. So that's kind of the basics of what you typically use. It's kind of fun, just real quickly to add to show how we can. You know what? I don't. Yeah. I would like to show push and pull, but I'm going to do that through the GUI just because we're running low on time. You can create another directory and add it as a remote and push and pull from it just locally to just kind of play with things if you like. But in this case, I want to keep us moving here. So let's see, the next demo I wanted to show off was push pull from the CLI. Yes. So let's, yeah, I think I need to skip that. So GUI activities. So now I want to get us into what does this look like? We kind of got some of the concepts in place, but seeing it visually actually really helps, I think. I'm going to use a tool. So there are a number of tools that are available for GUIs. Source tree is one that's available and popular mainly because it's free. There's another one that's kind of gaining notoriety called Fork. And it's $50. You can use it for evaluation. There's also one called Git Kraken, and that one is free for evaluation use or personal use. And so you can kind of use that, and yeah, easy to do that. I am going to. One of the tricks with Git Kraken is I wasn't able to wipe out my my repositories that I work on for work that are private. So I'm going to open the repository that we just made off screen so that I can kind of, so I can pull that up without showing off everything that's going on. Let's see, I need internal, talks, and then Git. All right, there we go. So, yeah, so here's what Git Kraken looks like. And so you can see how this is showing us a lot of the same information, but it's in a very visual format and easy to use. I don't have any connection to Git Kraken. I just think they make a good tool, and we use it internally at Dojo 5. But yeah, you can see I've got largely the same commits, and it's a nice way to explore it. We can see that the master tag, or the master branch really, is pointing to this commit. The check mark means that we're on that change set, and that's where the head is, right? And so if we made another commit, it would be built upon next change and added the main function. We can actually explore very easily inside of here, like what changes were part of that commit. So like when I click on the different commits, you can see that like here main was added, here main was edited. I can click on the particular file and see what the differences were in here. And there's a lot of other, obviously, like tools in here. We can see our commit hashes right here, which is, again, very valuable. There's that 23E6F2 that we had before. That's valuable when you're talking to other people or just kind of communicating about how these Git changes are working. And so, yeah, and again, we've done nothing here to push or pull anything to a repository. And so the what do I want to say? Right now we've done all this locally, and that's kind of the power of GitLab, is that you can create all of these tools. You can create all of these. I don't know. You can do everything you need to locally, and that's a lot of the power is just how fast this does things too. Okay, so let's set up. What I want to do is set up a remote so I can show you push and pull. And so the way you do that, I'm just going to pop up GitLab over here, or GitHub over here. And if you haven't done GitHub before, it's a popular one. You can get GitHub stuff for free. It's easy to do. When you go in here and when you sign up for GitHub, you create a repository. I'll just create a repository called I don't know, Git demo. Okay. Tells me Git demo is available. I'll make it public. Sure, why not? You can choose to initialize it with a README. And there's something called a Git Ignore, which we'll get to in a few minutes. So you can create this repository. Here we go. So now I've got Git demo. And important things to know here, they give you great instructions about using the CLI tool. In this case, we don't want to use the CLI tool. We want to use our Gui tool. A couple things, and this is really the piece that we need. There's two ways to connect to Git repositories, over HTTPS or SSH. I would highly suggest SSH. It's a little more modern, but the trick is it's a little harder to set up on the CLI. And I have some resources at the end of the presentation on how to set up SSH on Windows or on Mac OS or on Linux. So that it interoperates with Git's CLI system, but it is a little tricky, especially on Windows. So just know that. But I've set that up, and then we're going to use this guy right here to set up our remote. This is kind of the Git URL almost. And they'll basically, it's defining what's my username, my namespace. Here's my Git demo, name of my repo .git, and then. Yeah, but if you know that if you did want to do it from the command line, we could do it here. But yeah, if I want to add a remote, I can add a remote, repository name, new project. And what I'm going to add right now is just a URL. There's a push and a pull. And for very obscure types of situations, you might want your push and pull URL to be different. Most of the time, you just want them to be the same. All right, so I added a remote here. And now what I can do, and we'll see if it, you'll see some kind of tricks around push, but so it's saying what remote branch should master push to and pull from. Again, Git gives you a little too much power here. You can have your local branch named master and have it push to some other like branch called not master. That would be super confusing. I advise you not to do that, but there are some esoteric reasons why in some cases you would want to have different branch names there, but largely, Git Kraken's advising me not to do that anyway. So, all right. So, and now what we see in Git Kraken is push successfully master to Git demo. And now what we're seeing is that this is where master is on my local machine, and this is where master is on my GitHub profile. So now I've got those changes out on the website. And if I flip back to the website and refresh, now I've got my main.c out here. I can see that I've got one branch, it's called master. I can see that I have no tags. I can see my my history. If I look at my commits here, there's the kind of largely the same thing. Again, here's my commit hash. So pretty straightforward on how to do that. Let's get to, so that's kind of how pushes and pulls work. If we wanted to do that from the command line, now that remotes are set up, we can pull from that, and it says, hey, already up to date. So it's actually gone out to GitHub there and checked. And if we, let's say that we wanted to add a README, and I'm going to do this through the GUI. This is my demo. And commit new file. So this is kind of doing it through the website. So this is something that my local machine is not going to see. So then when I go back to Git Kraken, we'll see as soon as it refreshes, yeah. So now what's happened is, my master, the branch out on GitHub has diverged from master, the branch out on my local machine. And now we got to figure out what to do. We could rebase it, or we could merge it. And actually at this point, we don't need to do either because it hasn't actually, I haven't made a local change yet. But let's say I did. Let's say I made another change of like, hi guys, or whatever. Not even a compiling C program, but let's just say so. Now you can see this is a work in progress. This is the way that Git Kraken handles the staging area and stage files, but I can stage that file. It's the same as doing an add, give my commit message, added stuff, committed that change. Now we've got a true divergence. Now we've got a problem. We got master in two different places. Easiest way to do this is merging. And the way that Git Kraken does this is you can drag these things and we can choose to either rebase, interactive rebase, or where's my merge? Oh, we can merge, yeah. Merge Git demo master into master. And so now you can see it actually merged just fine without any conflicts. So we didn't have any issues there. Rebase would have done largely the same thing. let's say that I had, and now you can see too that one of the tricks here now is that I'm now ahead of master, and it actually shows me I'm 2 commits ahead of master out on GitHub. So now to share that change with everyone else, I push, and then you'll see this master. Now those 2 master tags out on GitHub and locally on my computer are both pointing to the same place. So now we're kind of back to the place we wanted to be. You know what? This ran a lot longer than I thought it would, and I'm running out of time. I'd like to have an opportunity to give you guys to answer questions. I don't see any questions out there yet, but feel free to toss those out. I was hoping to get through, so some real, I guess, just some quick advice from some newbies. It's a slog, don't give up. Rebase interactive mode is another thing. I didn't get a chance to show you that today, but something that I'd be happy to follow up with you after this and give you some resources on Rebase interactive mode. That's a kind of a power tool in rebasing that helps. Merging, what I didn't show just now with merging is that merging direction can matter depending on what you're doing, and making sure that you're going, merging from and to the correct code lines, the direction matters. And then remotes upstream, downstream can matter as well. I did show you that those remotes, but in the case where you're working on like an open source project, you might have an upstream repo or a downstream repo that you're working on. Another thing, yeah, so we can talk about that. Another thing from an embedded side is the Git Ignore. So on Dojo5 website, we've got some information. Follow up with me, afterwards if you want that, about Git Ignores specifically for embedded systems. So as you and I know, like in different IDEs that you're using or different build output, like typically you don't want to check in like the build output, the hex files, or all of the intermediate files, all the object files that get built when you're doing embedded work. And so Git Ignore is a way to keep those files from like kind of polluting your list of modifications. If you've got one C file you modified, but you did a rebuild and now you've got 300 object files, it's kind of hard to pick out where the C file is. So Git Ignore is a big deal. It just helps you ignore particular files. The other thing around here is large files. Typically in SVN and others, we didn't really care if we checked in like big, huge binaries. And it wasn't particularly fast, but nothing was really particularly fast. So it didn't hit us as much. It's a bigger deal in the Git world. Normally, it's just a bad idea to check in these big. Normally, binary files are the output of a large build, and really, we want reproducible builds, and we only want the stuff that creates those, the source code, to be in the version control, because you can't really version control binaries anyway. But in specific cases where you need to, LFS is an extension for Git that helps it handle binary files really well. I did get a question about project structure and folders. I think, largely, what do we typically do? We typically have a tools directory where we have often a file called build.sh, and that's our shell file for build. Or if you're on Windows, build.bat, and that's that just kind of encapsulates whatever I need to do to build. It's all there. I can just run that one script. I don't have to look up anything, and I can run it. And we tend to run our builds from the command line because we end up doing a lot of continuous integration, continuous deployment, automated build kind of stuff that I've talked about in other talks. And then a lot of folks will have a source directory. And oops, I wanted to move that up here. Well, there we go. And main.c would end up inside of there, and the README would be sitting at the root level. So a lot of times this is how our stuff would look. So hopefully that answers your question. Feel free to follow up if you have another thought on that. Let's see, I have another somewhat longer question. We have a lot of embedded development and often need to have code from SDKs committed into repos. Sometimes this leads to complications. Several chip vendors use clip-based tools and require creating workspaces which include a combination of their code along with the application code. Yeah, yes. The application development typically happens for Nordic, typically happens within the installed SDK directories, so it's a bit easier, yeah. So there are a couple of things. There are some power use cases with Nordic where you can use something called sub-repositories. I didn't get into that. It's kind of an advanced topic on Git. But that is one way that you can handle things like I have an SDK. Like when we do Nordic projects, we either we often have the SDK as a separate kind of build dependency that sits outside of the source repo. We don't typically check in the whole Nordic SDK. And then we reference it as a golden SDK, and you can use that either through subrepos or just through convention. And then if you need to make modifications to portions of the Nordic SDK, then at that time we pull in just those portions of the SDK that we're making modifications to. It keeps the repo small. For things like Eclipse-based tools, yes, that is where the Git Ignore comes in a lot. I think there are a lot of Eclipse-based Git Ignore examples that help you, especially for C when it's been hacked onto Eclipse, inside of some other embedded developers, or IDE that's largely Eclipse but just been modified. Finding those Git Ignore tools is a good way to ignore all of the build cruft and all of the stuff, because it is tool dependent really. VS Code has its own Git Ignore that we use. The Eclipse based tools have their own Git Ignore that we use, and they're very different. And some files you need to make sure they are checked in, and some files you don't. So it's largely related to that. Let's see. I am trying to I think we're out of time here. Thanks for the questions. Definitely, if you have any other questions about version control, Git, getting started, and specifically with embedded, we're here for you. Feel free to follow up. I've got my email address there. I have a cool Git quiz link as well that I thought was kind of neat that you can check out. And then, I think just reminder if we're all about, our mission for Dojo 5 is really about modernizing firmware. So not just Git, but as I mentioned, automated builds with CI/CD, firmware services, and we have all kinds of different tools to help you out with that. So with that, thank you so much. Appreciate your time.